Welcome back to the channel, everybody. I want to talk about error handling in C# and .NET. And honestly, I've read a lot of programming books, probably close to about 40 now, over the past 4 or 5 years. And one topic that I have not seen come up a lot, to be honest with you, is strategies for handling exceptions. Now, I'm not talking about try catch and throwing exceptions and having your API return the proper status codes and all that stuff. We got that. We know how to do that. I'm talking about strategies for actually how do you throw the exception? When do you throw the exception? How do you treat an exception in your code? Do you just want to inherit from the base exception class and create your own custom exceptions that you can throw? Do you want to actually create a result type that has, let's say, a fail state that you can then call at a later time? There's a bunch of different strategies, but strangely enough, I just don't see a lot of them talked about. In the object-oriented world, the traditional approach is to have your service throw, the exception, or maybe your repository throws the exception. Somewhere along the line in your service or repository layer, an exception is going to be thrown. My problem with that is, how do you know that exception is going to be thrown without prior knowledge of that part of the system? And that's where the complication arises. And that is part of an issue that is present in object-oriented programming. Is when you write nested code and when you have very hierarchical code, you have to have an understanding of what's happening at another spot in your system. And so if you have multiple services and one of those service methods throws an exception, what happens to the state of the rest of the system? How do you handle that exception? Because let's say you have method 1, 2, and 3, and you call them one after another, and each of those methods relies on data from a previous call, and you have, let's say, method 2 throws an exception for whatever reason, whether it's a null exception, whether it's, maybe the API that it's calling fails, it can't connect, whatever it is. Method 2 throws an exception. Well, what happens to method 3? What do we do there? So in our calling code, where we actually call method 1, 2, and 3, where we execute that code, we have to write logic to say, okay, well, how do we handle this, right? Do we want to throw the exception and thereby return that error code from our API? But if it's not an API, then what do we do? Do we want to say, okay, we're going to create a wrapper type, maybe a result type, if you're familiar with that, and we can have a failed state, a failed Boolean that we can set to true, and then we can check in the executing method. Do we want to set it up that way? How do we want to handle this? And my problem with this is that your calling method needs to have knowledge of what that method 2 does. What is the expected return? Can we have a null return? Can we have an exception that gets thrown? Can we have data that gets, returned? We have 3 possibilities right there that we just have to kind of assume is going to be the outcome, right? That's the object-oriented promise, is that something is going to happen, but we just have to accommodate for it. So if we have a null response, we have to check, is it null? We can do that by pattern matching, is null. We can do that by, maybe checking, is not equal to null, and then check that the count is not 0. We then say, okay, if it is null, we can throw a null exception. We can return out. We have to do something. But the problem with that is we have all those checks littered around all our different parts of our system, and all of that is very fragile. It's very brittle code, because you have to have so much knowledge of every part of the service, the layers, the methods, to write code that doesn't throw an uncaught exception, but 2, write code that makes it readable. And when you start throwing exceptions, the one thing you have to understand is, how is that exception going to be handled? Because let's say we don't know. Let's say we have our executing or our calling method that calls methods 1, 2, and 3. That main method, we have that using a try catch that throws that you know contains method 1, 2, and 3. So if that method 2 throws an exception, it's going to be caught by the base try catch, and then it's going to be handled there. But if it's not handled appropriately, that original exception can be lost. It's not gonna bubble up, for lack of better words. You'll hear that thrown out there. So we have to know, okay, how is this going to be treated? Do we want to return that error to the end user? Do we want to throw an exception? Do we want to bubble that exception up to the main try catch and then just continue, execution? What do we need to do with that? And so exception handling is a massive topic with so many different strategies, but it heavily dictates how you code to begin with. Because if you don't set up your code in a way where it makes it easy to throw exceptions, then you're going to have a difficult time. Because if you throw an exception and you have no understanding of where your method is being called, your exception might not be handled correctly. Or you risk displaying some kind of sensitive information to your end user that you maybe don't want to do. And so not only does it become difficult, especially as the system grows, but it's so important that when you design a system, you think about this up front. You have to ask yourself, how are we going to handle exceptions? How are we going to code for null values? How are we going to code for failures? How are we going to code so that if our data fails and we do throw an exception, that data is not lost, right? Because if you just have method 1, 2, 3, just, okay, we have a variable result equals method 1's execution. Then we have variable 2 is equal to method 2 with parameters from data from method 1's response. And, you can set it up like that. That's pretty standard object-oriented code. But my thing is that what happens if you change method 1? What happens if you introduce an exception that gets thrown in there? What happens to methods 2 and 3? Then we have to go back in and change, okay, well, if we throw that or if we return a null, we have to change it here, and we have to do all this stuff. And that's fine. You can do that, but I think there might be a better way. And so when you discuss exceptions, I think we have to treat exceptions as a primary driver for how we code. People like to talk about test-driven development, and I think that that's fine, but I really think that there should be another focus also on exceptions. And there is one style of programming that you may come across if you want to look this up, if you want to just apply a term to it, and it's called a railway-oriented programming. And it's more of a functional paradigm of programming. So if you come across functional programming is not something that I really thought much about when I started programming 6.5 years ago, but it's something that I'm trying to actively get better on, because I've run into all the issues with object-oriented programming. And I've seen, or am beginning to see, a lot of the benefits of incorporating more functional code into an object-oriented world. And so I'm a .NET developer, and .NET, or C#, I should say, C# is a unique language in the sense that obviously it's an object-oriented language. But so many of the features in C# are very functional. And if you've ever used F#, a lot of F#'s features are kind of making their way into C#. One primary example of a more functional set of features within C# is LINQ. And LINQ is interesting because it allows you to kind of make a first transition into using functional programming. Now, it's not purely functional in the sense of, writing pure pure functions or binding or monads or anything like that, but it gets you closer to your goal. And so, one thing that you can think about in terms of railway oriented programming is trying to treat exceptions as the primary driver for how you chain your methods together or how you bind your methods together. So, binding basically or composing your methods is basically say, okay, we're going to take method one and we're going to pass the result into method two, but we're going to do that by way of binding. And one way you can think about this is that in .NET, there is a library for task parallel library that includes propagator blocks. Propagator blocks includes, or transform blocks, include data flow blocks. They include a method called link to, where it allows you to basically construct these bindings or this chain of method calls where you don't have the intermediary data structures of, okay, we get our result from this and we pass the result there. We can compose the methods together, so we have, okay, method one links to method two, and then method two links to method three, and we then create this pipeline where we can just push our data through. And that's a more functional approach, and it gets us one step closer to writing something that adheres to railway-oriented programming. Railway-oriented programming, though, necessitates that we not only handle exceptions on a global scale, but we handle exceptions in a way where everything, our code basically adheres to the same exception handling logic. And so if we construct this pipeline, what we can do, basically to take advantage of a built-in feature with tasks, is we get a continue with method that we can leverage. So once a task completes, the next thing that follows is going to be, okay, this continue with, if we define it. And the nice thing about this is that we can write exception handling logic, so that if an exception is thrown on the method that's chained in our library, oops, our camera's out of focus. Here we go. If an exception is thrown in one of the methods that's chained, we can catch that. We can throw that, and then we can fault. We can raise a fault that then gets propagated. If we turn that setting on, gets propagated to the next method, and then it's going to be caught, and we're going to handle our exception. So it's a very functional approach, because if we need to add something into that chain, we don't have to do anything extra in terms of exception handling. All we have to do is, okay, we want to introduce method, 4. We want to add it to the chain. If we don't want, let's say, okay, if method 4 calls some API and it errors, we want to throw this exception. We don't have to add any custom exception handling logic. We can just throw our exception. It's going to be handled by our propagator block. That is just one example among many of a more functional approach to coding that adheres more to a railway-oriented programming perspective of exception handling. But again, that's just one example of many different designs and strategies. And it's so interesting because I just fascinated by the fact that there's just not more discussion about strategies in general API design books outside of the ones that are strictly functional programming. And I don't know if it's just because exception handling is like one of the core benefits of functional programming, or it's just like API design books just don't focus on it that much. It's so fascinating to me. I've read a lot of them, and a lot of them seem to cover the basics. Again, try catch, custom exceptions, all that stuff. But and retry policies and circuit breaker patterns and all that stuff. But nothing gets to the root of the problem to say, how is it handled in the code, and how do we write code that doesn't force us to add all this code that just litters our code base of custom exception handling. And so functional programming kind of solves part of that in terms of allowing us to write code that's not only easily extensible, but it easily allows us to not have to worry about littering all these checks in place and handling all these this custom exception logic. So it's very fascinating. It's such a big topic, and it kind of goes in line, at least from my perspective, with logging. Logging, at least logging correctly, is also a huge topic, because what do you want to log? What data is valuable? What are we treating as data? Is data just the response from your APIs, or is data could be also the chain of events that got you there? And it's so fascinating to me that logging strategies are also not more talked about, because that is a huge topic, right? Because what happens if you throw an exception? Should that exception? Okay, if we set it up, okay, that'll get logged. But what do we do with that log? No, really, what do we do with it? Do we just send it off to our whatever logging provider we happen to be using? Do we just send it there, and do we have alerting wired up to that? Do we that arguably is step one. That's really an assumed step that we're doing that, but we could take that a step further in a functional paradigm, because we could say, okay, well, if we do raise an exception, or we throw an exception for that matter, we need to handle that log correctly. And part of that might be, okay, well, if in our pipeline if something breaks, right, we throw an exception, let's log how we got here and what the state of the system is, as a way to get us hopefully back to where we were. So if we need to send that off to some other place, some kind of data store to house that information, so we can then retrieve that again and retry it. I mean, retry strategies are you can read a lot about those, but that's really the main idea of the whole thing, right? Because what value do logs add if they don't really tell us anything about the system, right? Logging for the sake of logging is not very useful. And logging is like an art in programming. It really is, because we all can write log statements and log, whatever. But writing something that's actually meaningful, that's going to allow you to debug the system later, is a whole different thing, right? It's really, it's an art. It's very creative, because you have to think in the future. You have to think, okay, when our engine API, our engine simulator, when that inevitably breaks, how in the world am I going to diagnose the issue? And you have to put yourself in the mind, okay, in the future, what am I going to be thinking in the future? What am I going to be checking for? And so writing logs is very difficult, because you have to think ahead of time and say, okay, when this breaks, how am I going to fix it? It's very difficult. And again, I could talk about so many of these topics, but there's so many just strategies and approaches that you can take to just honestly just help you out just in coding. And functional programming in the context of C# and .NET seems to solve a lot of issues, and seems to produce cleaner code, right, for lack of better words. I don't know. I might try to make more functional programming related content on this channel, especially as I see how it solves a lot of issues that, not issues, but it solves a lot of difficulties. How about that? It solves a lot of difficulties with object-oriented programming in .NET. So maybe that'll be helpful. Maybe that'll be fun content to make. So anyway, thank you all for watching. I'll see you in the next one.